All right, so let's graph some quadratic functions. So let's start with the very basic one, f of x equals x squared. Okay, so to graph a function, all we need to do is plot some points. So let's find these values. So what is f of 1? So remember, if I say f of 1, that means plug 1 into the function. So f of 1 would equal 1 squared. And 1 squared, of course, is 1. So we plugged 1 in for x. So here's the x-axis. Plugged 1 in for x. The function spits out a 1. So we plot a 1 on the f of x axis. So this axis is f of x. All right, f of 2. So f of 2 means plug 2 in for the x in the function. So f of 2 would equal 2 squared, which would be 4. So if I plug in a 2, the function spits out a 4. f of 3. So f of 3 means to plug 3 in for x, and we get 3 squared, which would be 9. So if I plug in a 3, the function spits out 9. f of 4. Well, that just means 4 squared. So that would be 16. Plug 4 into the function spits out a 16. All right, what about the initial value? So remember, initial value means f of 0, or the y-intercept. So initial value is the same thing as the y-intercept. So we plug, well, I wrote that in the wrong spot. Try that again. Initial value means f of 0. So I'll plug 0 into the function. I get 0 squared. 0 times 0 is, of course, 0. So if you plug 0 in for x, the function spits out a 0. All right, f of negative 1. Well, that just means plug negative 1 into the function. So f of negative 1 would be negative 1 squared. Negative 1 times negative 1 is a positive 1. All right, so if I plug negative 1 into the function spits out a positive 1. So let's plot that. Make sure it's essential that you have these parentheses around the negative 1. And these parentheses around the negative 1 means to square the entire thing. So this means negative 1 times negative 1, which gives you a positive 1. You cannot write, this is not correct. You cannot do this. This just means to square the 1 and make it negative. So it means negative 1 times 1. 1 times 1 is 1, so your answer would be negative 1 in this case. Okay, so these parentheses are essential. You must have the parentheses around the negative 1 or it's not right. This is wrong. Okay, so make sure parentheses are around the negative 1. You have to square the whole thing. This just means to square the 1, then make it a negative. So incorrect. Up here, notice some of them I wrote parentheses, sometimes I didn't, because it didn't make any difference. Here, for instance, if I put the parentheses around it, it still means to square the 2, so it means 2 times 2. Here, it still means to square the 3, so it means 3 times 3, and it means the same thing. So if the number that you're inputting is positive, it makes no difference. But if it's negative, it's essential that you have the parentheses. All right, get rid of this mess. All right, negative 2. So I plug negative 2 into the function, I get negative 2 squared. Negative 2 times negative 2 is 4. So plug in a negative 2. I get a 4 out. Get that. F of negative 3. That means negative 3 squared, which would be 9. And let's go ahead and do the negative 4. That means negative 4 squared, which would be 16. So let's plot those points. Negative 3 squared is 9. Negative 4 squared is 16. What about all the numbers in between? So say I plugged in a 1/2 or a 1.5 or a 2.3 or a 2.7. Do I get numbers out of it? Okay, so let's ask some of those questions. Let's start with 1/2. Let's plug in 1/2. So f of 1/2. So I'm going to plug in a 1/2 right here. What do I get out? So plug 1/2 in for x. I get 1/2 squared. Well, 1/2 times 1/2, we'll work this out really slowly. 1/2 times 1/2, 1 times 1 is 1, 2 times 2 is 4, so you get 1/4. So if I plug in 1/2, I get a 1/4 out. So I would get this point. Let's try another fraction. Let's do 2.5. Okay, so let's plug in 2.5. So f of 2.5. All right, let's write 2.5 as a fraction. So 2.5 as a fraction would be 5 divided by 2. If you divide 5 by 2, you get 2.5. So f of 5 over 2, that means 5 over 2 squared, which would be 25 over 4. Well, let's write this as a mixed number. How many times will 4 go into 25? 4 will go into 25 6 times. 6 times 4 is 24. So I would have 1 left over, and I would get 6 1/4. Or you could say 6.25. Okay, so if I plug 2.5 into this function, I would get 6.25. So 4, 5, 6.25 is about there. Let's see, get that. So in fact, you could plug in any fraction you want on the real number line. You could do negative fractions. Anything else, you would always get an answer. What about irrational numbers? So let's plug in f of the square root of 2. Okay, that's an irrational number. The square root of 2 is a number between 1 and 2, because 1 squared is 1 and 2 squared is 4. The square root of 4 is 2. The square root of 1 is 1. So the square root of 2 has to be between 1 and 2. And in fact, it's about 1.4. So it's about somewhere right in here. There's the square root of 2. What if I plug the square root of 2 into this function? Well, that would be the square root of 2 squared. If you square a square root, then you obviously get back where you started, and you just get a 2. And you see here's 2, so if I plug in the square root of 2, I get 2. It's right there. So you can plug in any irrational number. And in fact, you can plug in any number you want on the real number line, and the function will always spit out a value that lies right on this curve. Missed that dot, it's cheap. And this curve, as you guys probably know, is called a parabola. Parabola. It's worse all the time. All right, so that's called a parabola. Okay, this point down here at the bottom is called the vertex of the parabola. So that little point down at the bottom is called the vertex. All right, so let's talk about the domain and range of this function. So recall that the domain of a function is the set of all numbers that you're allowed to plug into the function. Okay, so as we mentioned a few minutes ago, I can plug in any number on the real number line. Okay, so I can plug in any real number to this function, and you will always get an answer. So that means the domain is all real numbers. You are allowed to plug in any real number you want, and you will get an answer. Another way of writing all real numbers is in interval notation. And we could say from negative infinity to infinity. We're allowed to plug in any real number on the number line from negative infinity, as far that way as you want to go, to positive infinity, as far this way as you want to go. All right, what about the range of this function? So the range of a function is a set of all numbers that the function spits out, the set of all numbers that are outputs of the function. So what numbers does this function output? Okay. So it outputs a 0 right here. It outputs a 1 here. It outputs a 4. It outputs a 9. And it outputs everything in between, like 6.25. So every number from 0 up this way is an output of this function. Well, the crows are back. Numbers down this way are not outputs of the function. So this function will never output a negative number. Negative 3, for instance, will never be an output of this function. That's obvious because anytime you square a number, your answer is always positive. You can never get a negative answer. So the range of this function is from 0 to infinity. So let's write that in interval notation. We're going to go from 0 to infinity. Infinities will always get an open parenthesis. 0 is included in our set, so we're going to use a square bracket for that. So the square bracket means the 0 is included. Infinities always get an open parenthesis. So the range is a set of all real numbers from 0 to infinity, including the 0. Another way of writing this is just to say that, we'll say y, since it's the y-axis. Y is greater than or equal to 0. All right, let's graph f of x equals x squared plus 4. All right, so first of all, let's find the initial value. Remember, initial value is the y-intercept, or it's the value you get by plugging 0 in for x. So it's f of 0. So if I put a 0 in for x, I would have 0 squared plus 4. 0 squared is 0. 0 plus 4 is 4. So if I plug 0 into this function, the output is a 4. All right, f of 1. So I'm going to plug 1 in. 1 squared plus 4. 1 squared is 1. 1 plus 4 is 5. And let's just do some of these. So f of 2, that would be 2 squared plus 4. 2 squared is 4. 4 plus 4 is 8. All right, let's plug in a 3. So that's 3 squared plus 4. 9 plus 4 is 13. And let's plot those points. So if I plug in a 1, I get a 5. Here. If I plug in a 2, I get 8. So there's 5, 6, 7, 8. 4, 5, 6, 7, 8. So if I plug in a 2, I get 8. If I plug in 3, I get 13. 9, 10, 11, 12, 13. Good. All right, let's try some more. So if I plug in a negative 1, that would be negative 1 squared plus 4. Negative 1 squared is 1. 1 plus 4 is 5. So plug in a negative 1 and I get a 5. You can probably guess what will happen if I plug in a negative 2. I should get an 8, right? Because this parabola is going to be symmetric around the y-axis. Okay, so if I plug in a negative 3, I would get a 13 because it's symmetric around the y-axis. So I would get a parabola that looked like this. Let's work these out on here. Negative 2 squared plus 4. Negative 2 squared is 4. 4 plus 4 is 8. Negative 3 squared plus 4. Negative 3 squared is 9. 9 plus 4 is 13. So we got what we expected. Notice what happened. This plus 4 took the parabola that we had a few minutes ago, and you can kind of still see that here where I erased it. It looked like this. Where the vertex was at the origin, and this plus 4 shifted the vertex up 1, 2, 3, 4 spots. This point was at 1, 1. It got shifted up 4 spots. So it went from 1, 1 up to 1, 5. This point was 2, 4. It got shifted up 4 spots, and now it's at 2, 8. This point was 3, 9 on the old parabola. It got shifted up 4 spots. It's now at 3, 13. 9 plus 4 is 13. Same thing over here. This point was at negative 1, 1. It got shifted up 4 spots. It's now at negative 1, 5, and so on. So every point on this original parabola, y equals x squared, got shifted up 4 units. So this plus 4 out here on the end just took the basic parabola, y equals x squared, and shifted it up 4 units. All right, so let's graph f of x equals x squared minus 9. Based on the previous example, you can probably guess what this minus 9 will do to this original parabola. Okay. What do you think it's going to do? All right, let's graph some points and find out. All right, so let's find the initial value. Remember, initial value means f of 0. So if I plug 0 in for x, I would have 0 squared. 0 minus 9 would be negative 9. If I plugged in 1 for x, 1 squared is 1. 1 minus 9 is negative 8. If I plug in a 2, 2 squared is 4. 4 minus 9 is negative 5. If I plug in a 3, 3 squared is 9. 9 minus 9 is 0. If I plug in a negative 1, negative 1 squared is 1. 1 minus 9 is negative 8. If I plug in a negative 2, negative 2 squared is 4. 4 minus 9 is negative 5. If I plug in a negative 3 squared is 9. 9 minus 9 is 0. So let's plot those points. Initial value is negative 9. F of 1 would be negative 8. So I plug in a 1, I get negative 8. If I plug in a negative 1, I get negative 8. It's a little crooked. If I plug in a 2, I get a negative 5. If 1, negative 2, negative 3, negative 4, negative 5. Plug in a 2, get negative 5. If I plug in a negative 2, I get a negative 5. If I plug in a 3, I get a 0. If I plug in negative 3, I get a 0. Let's do some more. Let's plug in a 4. Okay, so if I put a 4 in for x, 4 squared is 16. 16 minus 9 is 7. 1, 2, 3, 4, 5, 6, 7. So plug in a 4, and I'll get 7. If I plug in negative 4, I would obviously get 7 again. And so you see that you get this parabola. Man, that's really ugly. Not the best drawing in the world. All right, so what happened? This original vertex got shifted down 9 units. So this point was at 1, 1. Now it's at 1, negative 8. It got shifted down 9 units. This point was at 2, 4. 4 minus 9 is negative 5. So that point got shifted down 9 units. So every point on this original parabola got shifted down 9 units. Okay, so that minus 9 out on the end will shift the basic parabola, y equals x squared, down 9 units. All right, so let's answer some basic questions about this function. First of all, what's its domain? Okay, so domain, again, is a set of all numbers that you're allowed to plug into the function. Well, I'm allowed to plug in any real number to this function on the real number line because I can multiply any real number by itself and then I can subtract 9. So the domain is from negative infinity to infinity. It's all real numbers. And what about the range? Remember, the range is a set of numbers that the function spits out. Well, this function never spits out any numbers less than negative 9, but it spits out every number greater than or equal to negative 9. So my range is from negative 9 to infinity. And the negative 9 is included, so it gets a square bracket. Now, what about the roots of this function? So you can look and already see what the roots are. Remember, roots mean x-intercepts, or they're also called the zeros of the function. So there's a root. And right there is a root. Okay, so my x-intercepts are at negative 3 and positive 3. So those are the zeros of the function. The roots are the x-intercepts. Let's find these algebraically. Okay, so if I wanted to know the roots of the function, I want to know the x-intercepts of the function. To find the x-intercepts, I want to know what x value will cause the y value to be 0. So I want to plug 0 in for y. So I want to put a 0 here and get that. And so I want to know what x value will cause my function to output a 0. So I want to set the equation equal to 0. So you guys know 2 different ways of solving this now. You can factor it. This is the difference of squares. So it'll factor as 2 conjugates. Or more simply, I can just add 9 to both sides and then take the square root of both sides and get x equals plus or minus the square root of 9. So x equals plus or minus 3. So positive 3 or negative 3, just like you can look and see on the graph. All right, so let's graph this quadratic function. Notice this time the minus 3 is inside of the parentheses. All right, so let's plot some points. First of all, the initial value. Of course, initial value means f of 0. So if I plug a 0 in here, I would get 0 minus 3 squared. So we got to do what's inside the parentheses first. 0 minus 3 is negative 3. Make sure you got the parentheses around the negative 3 squared. Negative 3 squared is 9. So if I plug a 0 into this function, I get 9. And if I plug 1 into this function, so 1 minus 3 squared. 1 minus 3 is negative 2. So I have negative 2 squared, which would be 4. So I plug in a 1. The function spits out 4. And plug in a 2. So that would be 2 minus 3 squared. 2 minus 3 is negative 1 squared. Make sure that you got the parentheses around the negative 1. Negative 1 squared is 1. Just plug the 2, and I get a negative 1. If I plug a 3 into this function, okay, so I have 3 minus 3 squared. 3 minus 3 is 0. 0 squared is 0. So I plug in a 3, the function spits out a 0. What about f of 4? So if I plug a 4 in, 4 minus 3 is 1. 1 squared is 1. If I plug in a 5, 5 minus 3 is 2. 2 squared is 4. If I plug in a 6, 6 minus 3 is 3. 3 squared is 9. If I plug in a 7, 7 minus 3 is 4. 4 squared is 16. Okay, so let's plot those points. So I plug in a 4, and I get a 1. I plug in a 5, and I get 4. Plug in a 6, and I get a 9. Plug in a 7, and I get a 16. Completely off on it. All right, let's do one more. What if I plug in negative 1 to this function? Okay, so what's negative? We'll write it out right here. F of negative 1. So that would be negative 1 minus 3 squared. Negative 1 minus 3 is negative 4. And negative 4 squared is 16. So if I plug in negative 1, I get 16. And my parabola looks like this. All right, let's think about what happened. So what did this minus 3 do to the original parabola? Okay, so the vertex on the original parabola, y equals x squared, got shifted 3 units to the right. And the vertex is now over here at 3, 0. Okay, this point, 1, 1, got shifted to 4, 1. So it got shifted 3 units to the right. This point was at 2, 4. Now it's at 5, 4. So it got shifted 3 units to the right. This point was 3, 9. And now it's 6, 9. So it got shifted 3 units to the right. This point was at negative 1, 1. If you shift it 3 units to the right, 1, 2, 3, you get this point, and so on. So what this minus 3 inside the parentheses does to the original parabola is shift it 3 units to the right. So notice that's backwards, or sort of seems backwards. It's a minus 3. Maybe you would think that shifted it left since it's minus, but it actually moves it backwards. So this minus 3 shifts the original parabola 3 units to the right. All right, let's try a new one. Let's do f of x equals x plus 2 squared. All right, so maybe you can guess what this plus 2 will do to the original parabola, the dotted one. Okay, let's graph some points and see if your guess is right. So let's start out with negative 2. So I'm going to plug negative 2 into this function. So f of negative 2 would be negative 2 plus 2 squared. Negative 2 plus 2 is 0. 0 squared is 0, so you would get this point. All right, let's plug in negative 1. So if I put negative 1 in for this function, negative 1 plus 2 is 1, and 1 squared is 1. So that would be there. Okay, let's plug in 0 to this function. 0 plus 2 is 2. 2 squared is 4. So that. Plug in 1. 1 plus 2 is 3. 3 squared is 9. So I would get that point. Plug in a 2. 2 plus 2 is 4. 4 squared is 16. So if I plug in a 2, I get 16. So I've got dots everywhere. I can't remember which one to go with that. Okay. This one. I left too many dots on the board. Can't tell what's what. There we go. All right, let's plug in negative 3. So if I got negative 3 plus 2, That's negative 1. Negative 1 squared is 1. Get that. Plug in a negative 4. Negative 4 plus 2 is negative 2. Negative 2 squared is 4. So get that. Plug in a negative 5. Negative 5 plus 2 is negative 3. Negative 3 squared is 9. So I get that. If I plug in a negative 6, negative 6 plus 2 is negative 4. Negative 4 squared is 16. That goes up there. And we get that. All right, so what happened to this original parabola, the dotted one? Okay, well, this dotted one got shifted left 2 units. So the vertex wasn't 0, 0. Now it's at 0 or negative 2, 0. This point was at 1, 1. Now it's at negative 1, 1. This point was at 2, 4. Now it's at 0, 4. This point went 2 units to the left. And this point, that's not really on there, went 2 units to the left. This point on the dotted line went 2 units left, and it's here, and so on. So that plus 2 inside of the parentheses moves the original parabola 2 units to the left. All right, so last example here. Let's look at f of x equals x plus 3 squared minus 4. Now let's think about what the vertex of this function would be. Well, what does this minus 4 out on the end do to the original parabola? And by original parabola, I mean y equals x squared. So the vertex of the original parabola is at the origin, at 0, 0. So this minus 4 should shift that original vertex down 4 units. And what does the plus 3 inside of the parentheses do to that vertex? Well, remember, this number inside the parentheses shifted the parabola left or right, and it was opposite of the sign. It was kind of opposite of what you thought it would be. So a plus 3 shifted it left 3 units. Okay, so the vertex of the original parabola is at the origin. So it gets shifted left 1, 2, 3 units and down 4 units. So the vertex of our parabola should be at negative 3, negative 4. So notice the x-coordinate of the vertex is the opposite of this number, and the y-coordinate is that number. All right, what about the initial value? Well, to find the initial value, I plug 0 in for x. So if I put a 0 in for x, I get 0 plus 3 squared minus 4. 0 plus 3 is 3, so 3 squared minus 4. 3 squared is 9. And 9 minus 4 is 5. So my initial value would be 5. 1, 2, 3, 4, 5. What about the roots of my function? Well, to find the roots, I plug 0 in for y. I'll have 0 equals x plus 3 squared minus 4. You guys know how to solve that. I'm going to add 4 to both sides. Then I'm going to take the square root of both sides. That will give me x plus 3 is equal to plus or minus the square root of 4. I'm going to move the 3 to the other side, subtract 3 from both sides. I get x equals negative 3 plus or minus, and the square root of 4 is 2. So negative 3 plus or minus 2. Negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. So my roots are at negative 1 and negative 5. So here's negative 1 and here's negative 5. Those are my roots. So my parabola then would look like this. Okay, so anytime we graph a parabola, I'm going to always expect you to find the vertex the roots, and the initial value. Let's plot some other points just to see if we are on the right track. So let's put in, let's plug in -1 to the function, make sure we get a 0. So if I put in -1 plus 3 is 2. 2 squared is 4. 4 minus 4 is 0, so that's right. Let's plug in maybe -2. Okay, so if I put in -2, -2 plus 3 is 1. 1 squared is 1. 1 minus 4 is -3. So if I put in a 1, I should get a -3. And if I could draw a really good parabola, I would have hit that dot, so it's right where it should be.